I'm John Creevy. I'm an HVAC certificate program student at Triton College in River Grove, Illinois, in the Electrical and Controls 1 class in the spring of 2026 with Professor Gregory Sharp. Today, I'm going to review the order of operations for this Goodman GRVT80 ECM variable speed two-stage 80% natural gas furnace. Everything starts with 120 volts that gets supplied to the system board, where the system board has a control module that will continuously monitor all of the safety circuits in the furnace. Those include primary, now there's a hidden one, and auxiliary limit switches that are there in case there's a problem with the flow of air past the hot heat exchanger. In case that were to overheat, those limit switches will shut down the system to protect the system and the home. In addition, there are these flame rollout sensors that if the flame from the burner doesn't go into the heat exchanger as it should and comes back, those will trip, shutting things down as well. And then there are pressure switches for the flue. Okay, and then in addition, this is equipped with, and I know this is a furnace order of operations, however, this does involve the gas valve. So this is an AT2L cooling system running R32. So there is an R32 sensor. If R32 is sensed in this unit, because it's supposed to be sealed unit, not supposed to be sensed at all, it will shut off the signal to the gas valve because R32 is a flammable liquid. Now, to get the furnace going, once the set point of the thermostat is above the actual sensed temperature in the conditioned space, then the 120 volts will go down to this 24 volt transformer through the system board. It will supply the 24 volts to the R terminal of the thermostat, and then once that set point is above the measured condition space temperature, the contacts for the W terminal of the thermostat will close, and then that signal will come back down to the system board. It will start a 15-second pre-purge in high speed with the inducer blower motor, and then shut down, or not shut down, but reduced to a lower speed. And then the pressure switch should, if everything is okay and the flue is open and working correctly, sense a negative pressure in the flue. And then once that negative pressure is sensed, then the igniter will go on a warm-up delay, a warm-up period, and after the warm-up period, then the gas valve will open, sending gas down to the burners. And then back here, the flame sensor is another safety device or sensing device for the circuit, that as long as that flame sensor is sensing that there is a flame in the burners, as long as it's still being called for heat, the gas will remain on. Now, once the burners are running, the inducers running, then there is a pre-programmed delay for the, in this case it's an ECM centrifugal blower motor, and then that blower motor will run the air across the heat exchanger and heat the conditioned space. Now, there are algorithms also pre-programmed that can vary the speed of this motor along with the gas valve being two-stage, high and low gas being supplied. So once the air is being blown into the conditioned space, heating up the conditioned space, and the thermostat hits that set point, it then opens the contacts in that W terminal back to the system board. The inducer blower continues to run for another 15 seconds before it shuts off after, and it's before, well, the first thing that happens, the gas gets shut off, and then the flames stop in the burners, and the inducer motor turns on for that 15-second purge. After that 15-second purge, then the blower motor gets on a shutdown delay, also programmed. It'll be on high speed for the first 30 seconds and then low speed for the remainder of that shutdown. Once the blower motor shuts down, then the heating cycle is complete, and then the unit is waiting for its next call for heat.